Today we're gonna talk about fixed effect estimator and what's that. Okay, we take the example like this. We know that there are in US the amount of fatality because of the accident is pretty high. So let's say like we want to count that fatality, and fatality here it's depend on first, let's say, the amount of beer tax or tax on the beer, okay, and it varies over time. And then let's say the beta 2, we want to also count it, for example, spiritus consumption, that it's also changing over time. And then plus here is what we call it as external heterogeneity that we haven't counted, which is different from one city to the other, but it's constant over time. And then also what we call it as the idiosyncratic error. So what's this? The concept of consistent is like when we found the correlations or the covariance, okay, of one of these, let's say this is x1 and this is x2, the covariance between the external heterogeneity that we haven't counted here with one of the x, it should be 0. And it will be, because why? If this is not 0, we call it as a problem of endogeneity. And the issue here with the fixed effect that we want to solve is if there is correlation of 0, we want to like remove this. So we want this it's to be removed. But then how to do that? Let's say we want to remove this, and this is something that we called it before, the external heterogeneity, or something that we haven't discovered. Okay, let's say like if we want to take the average of fatality, like fatal here, it's the function of a mean from the time with start from 1, and then this is like fatality ET. Okay, so if we take this example, it will be like what? Fatality is actually the mean of B1 beer tax in every state or country E, B2 spiritus consumption of E, plus alpha that doesn't change over time, plus UA. Okay, and what is fixed effect? Fixed effect is basically we want to remove the external heterogeneity alpha here by subtracting the normal formula of fatality minus the mean. Okay, so if we use it in the equation or in the model, it will be like fatal minus fatality equal with B1 the beer tax minus the mean of beer tax plus B2 of spiritus consumption minus spiritus consumption means plus alpha 1 minus alpha 1 plus ui minus ui means. And in here then we can remove the x. So let's say like if this is become the new equation, then it will be fatal d mean, something like that, equal with b1 vertex d mean, okay, plus b2 spiritus consumption d mean plus ui d mean. So this is the new model or the equation, and we expect if we already remove this, then the covariance between xi d mean with alpha, it will be 0 because the alpha is gone. So then what's going on with this? The issue is with the fixed effects. Okay, we remove the time constant, and if we remove the time constant, it means that if there is something in the model, okay, I will write it here. If there is something in our model that does not vary over time, then we could not use fixed effect. Okay, how to see it in our Stata, we're gonna see in the next video. Now we're gonna try to use the command. So first thing we need to do is, like I'm going to use the data that I have it from the website. So if you guys see that this is useful, feel free to use this data. This data actually available in the internet on this name, like as you could see. First you have to use not HTTPS but HTTP, and then it's from connectivefreelancer.com/static media upload start tutorial emails traffic.csv, and don't forget to add comma in here. Okay, so if you click in data browser, you will get like data, tons of data that we already have, and I haven't actually segregated based on, I haven't set it up as a panel data. So there is a state with showing like what's the name of the state in US, the year of the observation, start from 82 until 88, and then this is like spiritus consumption, unemployment rate, income per capita, there is also beer tax, their web marriage, and we want to count actually the fatality on the street or the accident. Okay, so what things that now we need to find here is like we haven't set up the data here as panel data, and the issue is we are using the states which is string, and it cannot be used as the variable, because let's see, if we want to type like tss set state and then year, and then you will see like string variable not allowed. How to do it? First we need to make the again. This is like creating the new variable based on the numeric, and we will use state number, so make sure it will be like integer, and then here we will name it's like state or group of state. Okay, and then it will be enter, and then when we see here, you will see there will be already a new group called state numeric, and then this is like based on the which like state number. So if we want to check, we can actually select list state and then state num, okay, in 1 per 10, for example, like that, and separated by, for example, state. And we could see like Alabama, for example, state number 1, Arizona is state number 3, and so on. If it's like this, then we can set up the panel data easily by telling like state number and then what's the variable of the time, which is year. So you see it will be strongly balanced, state numeric, and so on. So if you, for example, want to summarize, you see like we have 36 variable that we want to see, like the state, the year, the spirituous consumption, and so on. And then what we want to calculate here is like the fixed effects calculation. Okay, so the simple way, for example, to do the we will compare like first this extract without the fixed effects. We put like fatal as the dependent variable, and then let's see, we put the beer tax, and then we put beer tax and then spiritus consumption, and then enter. As you could see here, like the overall of R square is like 0.03, which means it's not like so much representing data. And then the beer text, the coefficient is 0.9, spiritus consumption 1.13, and we could see also like how many the t square here, or the z square, sorry, because this is not like individual test, so we actually also see from the f. And the correlation here, because there is no fixed effect, the assumption is like there is no correlation between the error with the one of the variable. Okay, now let's put like fixed effect here, like x-T-rex, and then fatal, beer tax, and then spiritus consumption, and we will write it in fixed effect. Okay. So in overall, as you could see, the data here was 0.3, and now it's going increase to 8%. And the correlation, they will count like the error correlation with one of the variable is minus 0.7. So we assume it should be 0, but unfortunately it's not. And the f-test, it's quite significant. So there could be probability there is a correlation between one of the error on or unobserved heterogeneity with one of the variable. I mean, like, it's good that we see here, because fixed effects here, why? Variable that constant on the time, we do not include them. That's why we use it fixed effects. Okay, so this is how to see and read it, the fixed effect. Another question is then, like, what if we want to use fixed effects but we still want to put the assumption that there is like difference in the time? So as you could see here, like, we have the data, and we have also have what's going on, like the fatality in every single situations, but there is no variable year, and this is what we want to put variable year here. So let's see how to do that. First, we will quietly calculate here, and we will generate year here. Sorry, quietly calculate year, and then generate the year itself. Okay, and then we will take like local j here as one of the parameter, and then for values, e will start from the year of 82, to 87. Sorry, 87, and then open parenthesis. Okay, so from the time we want to have increase in terms of G, because G start from 0, and then we will rename the year from G into E, like time, and then quietly replace year from E, sorry, into year E minus year 7, because there is like there is 7 year of research here. Okay, and then we will close with parenthesis. There is like type mismatch. Okay, probably there is some error, so let me just take the value here directly. If you want to get the code, it's also available on the website. Let's see. Okay, something error, like type mismatch. Let me take a look. Local G. I should not put this local G here with parenthesis, unfortunately, so it should be like local G 0. Okay, and then I will just take and copy one more time here these 4 values. Okay, yep, and then as if we want to see like how the data browser look like, there is like year from dummy variable year 82, year 83, year 84, 87, and so on, and we want to drop year 7. Okay, and then we can start to extract fatal beer tax and then spiritus consumption, and then we also put the couple of variable that is year from the time, and then fixed effects. As you could see, like we put the consideration that before in fixed effect that we don't take any into account about the year that it's constant from time, but now we put it, and we could see there are something that we can analyze from time to time from 82 until 87 here. And then as you could see, like there are some years that it's like significantly affecting what's going on, like this D5, 4, F4, 4 and 5 to the dependent variable fatal. And here like the correlation also like changing the overall of the data, also like actually decreasing than before. So this is the way that if we want to put into account, we want to do fixed effect, but we still want to put into account what's going on from year to year, that before in fixed effect we don't put something like it's called time constant. Okay, so I hope it's helped you guys in understanding how to read the fixed effect and how to run the fixed effect and how to do the fixed effect but still putting consideration about year. Thank you. Hey, my name is Dimas. I'm from NotAfraid.id Institute. I'm a final year PhD student in Krakow University of Economics in Poland. I have published a couple of articles. At the same time, I'm also like a senior manager in one of the largest P2P platform startup in the world. And within the course, we will learn a lot of things connected with econometrics, because I understand that studying econometrics can be very challenging, because we try to find what's the theory and how it applies in the real world, and not everything's in the theory actually have the application in the real world. That's why during the course we will try to find what can be. So we will go through all the checklists that we have in the Stata course, and then after that we will see how it will be implemented in the code, and perhaps we will find everything's in the applicable way. So if you think everything's it's gonna be useful for you, please also consider to subscribe this channel, and also see you in the next course. And if you have a couple of questions, feel free to ask in the comment section. Okay, so see you in the next course, and happy learning. Bye bye.